welcome. Uh, how are you doing?
Very good, and you?
Yeah, fine, fine. We're fine. So, guys, lots of explanations today. Before anything we do today, I need to explain the core activity because this is due for the end of November. So it's the last entry, so the final delivery. I'm just going to show you what to do. It's available in Canvas already, but I just wanted to go over it with you that you don't leave it until the last moment because that's never the best, okay? So let me show you first the core activity thing. Then I will explain you the activity of tomorrow because tomorrow we will not connect. We will you will go to a park or something and do an activity which I will explain in a moment, and then we do evolution activity about the pocket mice, which is very nice. So first thing is this core activity. So basically it's your final delivery, and I think it's the most important delivery. And I will check it a little bit in more detail than I did with the other ones, because this is the part of the activity we will have to upload in Illumin, which is your online portfolio. So this is information that will be stored until the end of your sixth semester. In fact, it will be kept in a file which you will also get in a digital format when you graduate. So of course you want it to be nicely. So what is the last entry of the core activity? It has 3 points in the group activity and it has one individual part. So let's go first over the group activity. Um, so this is based completely on what you handed in already in the second delivery and the first delivery. So make sure that you join all that information, and in case you didn't do this properly, you still have the chance to correct what you did not do correctly in the second delivery. However, I believe that this group, most things were nicely done. There were one or two groups, I think, that certain things were missing. But let's go over it. So the most relevant information of what you presented in deliverables 1 and 2, okay? Here we want to see the definitions of biodiversity, culture, and cultural ecology of delivery 1 and delivery 2, okay? So basically you're going to make a very nice summary of what you already did. If something was bad, you have an opportunity to improve it, because if you're going to hand in something bad and hand it in again, that's not the idea. It's a chance to do it better, okay? Then after that, it's very important that you illustrate is putting pictures and describe the negative impact of the human activity that you have been analyzing, which is basically the agricultural thing of avocados or coffee or whatever you did, okay? And what I saw in the second part is it was very important for you to include, to do a little investigation about how this ecosystem changed in the last 50 years. And this was missing with several ones, you know, that you had to investigate a little bit what happened in the last 50 years, because it has been absolutely devastating. And it's very nice about your personal side that you investigated to have a deeper look to that, okay? And then the third thing is the positive part of the exercise, because you have to propose 3 viable and real actions you can do in order to to prevent and correct the damages caused by these activities. Okay, this includes the short term, the medium term, and the long term. Okay, check the rubric, like I always said, because some of you didn't do that. Check the rubric when you hand it in. It's available on Canvas. It nicely includes, it lists very well everything that your work has to include. So if you don't include something, you're already not going to get points for that. And the most simple example is it always says, it has to say your name, your matricula, and there are still students. In fact, it's points you get for free, and there are still students that do not put their names on their work. So it's basically losing points for nothing, because I mean, it's still incredible you get points in prepa just for writing your name, in fact, but it's the case. That's the part you do in the group, and the group, of course, is the same persons that you did delivery 1 and 2 with, okay? Then there is the individual part, and for me it's very important, this individual part as well, because you're going to write a personal review, okay? A personal review of 1 page. You're going to write it with Arial 12 interspace of 1.5, and it has to include introduction, argumentation, and conclusion. Of course, write your name, matricula, and group, and write the title on top of your review, and space it nicely out so that not everything is on one side. So you do that with this button here. You know, it's like the, I don't know how it's called in Spanish, but it's like the button that spaces the text really nice out. And guys, be careful, because the personal review is not answering these questions. It's not what aspect of your project are you the most proud on, and then you write me the answer. No, you're going to include the answer in your text. I don't want to see those questions in your work, but these questions are there to help you to know what you have to write about. So what are you the most proud of? What are the things that you have learned? What would you have done differently when looking back? What impacted you the most, and what do you think can contribute to saving biodiversity? So that are things that you link to your work and you make a reflection about it. These are example questions. You can include other things, you know, but it's just an idea what your reflection has to include. You know, you have to try to answer this kind of things. Is that clear for you? So that's why I wrote not just answering the questions, they have to be developed in your text. It means that I don't want to see those questions, you know, they have to be embedded in the text. So no question and answer, you indirectly give responses to those answers in the document you will write, okay? And writing is very important, guys. So I think it's a good thing, this personal review, because without the personal review, I mean, certain students, they graduate from tech and they don't even manage to write a nice document of 1 page. So this impress us with this, okay? It has to be nice. Okay, that's for the core activity. You know what to do. You have until...
How long does it need to be?
Sorry?
How long does it need to be?
Well, the collective part, the team part, it can be as long as you want. I'm not gonna limit you. You can see how long is useful. I would think it could be a bit longer than delivery 1 and 2 because they were very short in certain groups. Not your group though, Anapau. And the personal reflection is just 1 page. It's really not so big. So this here you can do. I mean, I suggest it should be 3 to 5 pages minimum, right? If you come with 1 page, I don't think it's going to be really nice. Okay, so to give you an idea of how long it should be. So that about the core activity. This is due for the 27th of November. And then there is the activity you will do tomorrow. So guys, we will not connect to Zoom, okay? The whole point is not connecting to Zoom and to give you some time off. So we will not connect to Zoom, and what you will do is the following. You take your mobile phone or your reflex camera or whatever you have, and you go outside. Okay, you can go to a park, you can go to your garden, you can go to the gardens around the desert museum. If you have a cabin or a cottage or a ranch or whatever, or you want to go to the forest, you can also do that, but I don't think the hour will be okay. So I give you time until Sunday evening to do this. So in case you want to do it in the weekend because you go to the rancho or I don't know where you want to go with your parents or maybe alone, then you can do it in another place. So it's very nice. You have to do it by the 11th of November, which is on Sunday, and you have to submit it in PDF or any file is fine, in fact, but it really has to be nice, okay? Of course, you cannot repeat the photo of 2 different things, and all the photos have to be nicely taken, okay? Make it beautiful. So what are you going to do is you see 15 concepts here. So I want to see 15 pictures, 15 photos. And you go into nature and you go take a picture of order and complexity in organisms. Remember, this is a characteristic of life. And there is many examples of order and complexity in organisms. So I give you one example, but please don't all come with the same thing. But for instance, if you find some kind of spider web and you take a picture of a spider web, you can do that and put it number 1. And of course, it's very important that the photos, they must be labeled, because the idea and the objective is that I understand, or that I see that you understand what each concept is. So order and complexity in organisms, you write that on top of, you glue that or you write that on top of the picture of the spider web, to give an example. And you're going to take a picture of the ecosystem, chloroplast, organism that reproduces sexually, the main origin of all energy. There is other examples. Of course, it does not have to be a perfect match always, okay? Just try to take something that is obvious that I see, that it's obvious that you know what the concept is, okay? It's not very difficult. I hope you enjoy doing it and make something beautiful. Make a nice collage. Of course, I also take a selfie, okay? Name your organism according to the taxonomy we have seen yesterday. So it's basically the name of our species. We are all of the same species. And then your selfie and your name, of course, okay? 15, I put it optional because some of you, they don't have the possibility to go to the rancho or to the forest or whatever. And if you have to go to a park near your house or in your garden, fossils are not that available in the city. I mean, they're everywhere. If you go in the desert, if you go to the canyon, if you go to other places, just hit the rock breaks open and you will see fossils. But if you don't really have immediate access to a fossil, you can do something else there. But in fact, I don't know if you know that, but Coahuila used to be sea, and fossils are everywhere, guys. If you go to the way Torreon, there is this village, Estación Marte. It's full of fossils. If you go to the desert, just hit a rock, and you have a good possibility, if it splits open, that you will find a fossil. In the San Lorenzo Canyon, you can even find fossils. I've even seen fossils in a park in La Colonia Doctores. I was there playing with my kids and I even saw fossils there, but I'm not going to oblige you because I know it might not be possible for everybody. But fossils, I mean, we live in a state of Mexico where fossils are very readily available and they're quite easy to find because they're everywhere. I mean, if you go to Belgium, I mean, we never found any fossils because they are just not there. But here, there's everywhere fossils, so that's really nice. I mean, we even collect them. I have some fossils in front of my door of my house here that we found with some shells and stuff. So they're everywhere. Okay, so this brings us to the activity of today. And the activity of today is nice because, in fact, this is a perfect proof we have nowadays that evolution is true and that evolution is happening. And it's about mice. It's about mice that live in the desert. They also live in Mexico, but in United States, in New Mexico, something special happened in the last 1,000 years. In fact, what happened is that the desert sand used to be always like you see on my background, you know, it's like typical desert sand that is like sand color, you know, this brownish, yellowish color. But there were some volcanic activity in the desert, which caused the desert sands to be covered with a darker colored lava. And what happened is that the mice, which usually had light fur, the pocket mouse it's called, they had light fur and they changed into dark fur. And of course, it's because they needed to adapt to their environment. And that's what the activity is about today, that you really witness this evolution for yourself. So let me go there quickly with you because we need certain things to do that. I'll show you. About this activity, guys, what I wanted to tell you is that you can do it in groups and you can do it with the people that you choose, but you can be maximum 3 persons. If you say, I rather do it alone, you can do it alone. I'm not going to oblige you to work in group. So you choose, okay?
One of the rocket.
Sorry?
The one of the rocket mouse.
I don't hear you, Cecia.
The one of the rocket pocket mouse, right? Like,
Is assignment
I'll go there. I'll show you. It's the rocket mouse. The pocket, not rocket, pocket. A ver, it's this one here of the pocket mouse, indeed. So rock pocket mouse. And you will need also this Word file. So you download it. You can open it already. It's this one. I already have it open, I guess. So this is the document you do. It looks complex, but once you see the video, you will see it's not. It makes sense. And then you also need this kind of illustrations, okay? Because you need to count the mice. I mean, you don't see it that nicely, but there's one dark mice and there is like some lighter mice here, and you have to plot that in a graph. So it's just counting. It's not that hard, but it's a good exercise. So what are we gonna do is we watch the video together here during the class, and pay attention because it tells us all the information you need to know. And it's truly, truly interesting. Maybe you're not interested in mice that much, but think with eyes of evolution. Think through the eyes of evolutions, and you will see that this is really a marvelous example of how evolution is happening all the time. And it's even considered as a proof of evolution. Okay, so there we go. Have a look.
Across the American Southwest, golden deserts dotted by cacti and brush stretch for miles. Yet here in New Mexico's Valley of Fire, the landscape changes dramatically. Patches of black rock interrupt the sand, remnants of volcanic eruptions that occurred about 1,000 years ago. The eruption spewed a river of lava more than 40 miles long across the desert. As the molten rock cooled, it darkened, leaving any creature dependent upon camouflage in serious trouble. In the complex battle of life, one of the constant struggles is between seeing and not being seen, the evolutionary game of hide and seek. And we've come here to the Valley of Fire in New Mexico, a battlefield, to find one of the tiniest soldiers and what it can teach us about how evolution works. On the desert sands, the rock pocket mouse blends in perfectly, its light-colored fur concealing it from predators. But on dark lava, the same fur makes the mouse stand out, attracting the many creatures that see it as food.
These mice are the Snickers bar of the desert. They're eaten by foxes and coyotes and rattlesnakes, and certainly by owls, and maybe even occasionally hawks. And most of those predators are visual predators.
So what happened to the pocket mice that found themselves on this new terrain? When I accompany biologist Michael Nachman onto the lava, it doesn't take long to find out.
Oh, this one's closed.
Nachman has been collecting mice unharmed in traps. And it's a dark one.
It is, yeah.
Now, are most of the ones you find up here dark?
Almost all of them.
Not only have the mice here evolved to be as dark as the rock,
Shake them into the bag.
the color change has occurred precisely where it will conceal them from hunters.
A bit of a white underbelly, too.
That's right. All of the dark ones here and on other lava flows have a white underbelly, and presumably there's no selection for dark on the belly because predators are coming from above.
Left to themselves, the mice show no preference for light or dark rocks. It's the predators that have made the difference.
The change in color over evolutionary time in the population is driven by predators weeding out the mice that don't match their background.
But how did the dark mice arise in the first place?
When a black mouse appears in a light population of mice, that is usually going to be due to a new mutation. And those are random and rare events.
To fully understand the pocket mouse transformation, Nachman moves from the lava to the lab. He and his team extract DNA from light and dark mice taken from one desert region. The aim? To find one or more genetic mutations that cause dark coloration. A mutation is a change in the chemical letters that make up our genes. It's a copying error that may occur when our cells divide. Mutation seems to mean that something bad has happened. Well, mutations are neither good or bad. Whether they are favored or whether they are rejected or whether they're just neutral depends upon the conditions an organism finds itself. So for the pocket mouse, a mutation that caused the mouse to turn black, that is good if you're living on black rock. It's bad if you're living out in the sandy desert.
The light mice are all on the bottom, here.
Fur color is a trait controlled by many genes.
And it turns out that
To figure out how dark mice evolved, Nachman focuses on how these genes differ in dark and light mice. One by one, the genes prove identical, but at last, something does turn up. The difference between dark and light mice boils down to a difference of 4 chemical letters in a gene called MC1R. Because the gene controls the amount of dark pigment in a mouse's hair follicles, a mouse with these mutations grows dark fur, which gives it an advantage on a dark background. But still, that's one mouse. How would its dark fur spread to a whole population?
this lava flow is about 1,000 years old. And so you might wonder, has there been enough time? It's only been 1,000 years. It's a very short period of time for a new mutation to come along and spread, and so that all of the mice on this lava flow are black, because really they all are.
Indeed, such a rapid spread of a mutation may seem unlikely until you do the math. And the reason is that while only one new mouse born in 100,000 may be black, hundreds of thousands of mice are born in any given year. And then those mice that are black have enough advantage that their babies do better, and they have more offspring, and their offspring have more offspring. And just about a 5% advantage, compounded year in and year out, can very quickly turn the whole population black, as we see today. If dark color gives mice a 1% competitive advantage, and you start with 1% of the population being dark, then about 1,000 years, 95% of the mice will be dark. If instead, the dark color gives them a 10% advantage, then it only takes 100 years. Thanks to Nachman's mice, science has an example of evolution crystal clear in every detail.
What's exciting about this is that we have a system that's very simple ecologically. You have dark rocks and you have light rocks, and you have dark mice and light mice. It couldn't be simpler.
We know who the predators are, what the selective force is. We know precisely the genetic basis of what makes the mice have an advantage or a disadvantage depending upon where they live. All the pieces are finally together. It's a perfect illustration of Darwin's process of natural selection. In fact, it's more than that, for Nachman's mice also counter a common misconception that evolution is a random process. Well, there is one random component, and that's the process of mutation. Mutations occur at random throughout our DNA. Every new organism is born with a new set of mutations. But while mutation is random, natural selection is not. Natural selection sorts out the winners and losers. And that's really what the whole process of evolution is driven by. But if natural selection is not random, would it produce the same result under the same conditions? It does. And here's proof. Rock pocket mice collected by Nachman from other lava flows in other parts of the Southwest.
These are two different black mice, and they each evolved on different lava flows, and the lava flows are hundreds of miles apart. But the changes, the genetic changes that made these mice black, were different in each case. And what's amazing to me is how similar the black mice are. We didn't know when we started this whether we would find that there were the same genes or different genes, and we were really surprised to find that they were completely different genes, and yet if you look at the mice, they look almost identical.
Clearly, there are different genetic ways to make a mouse dark. But once the beneficial mutations appear, natural selection, the non-random part of evolution, can, under very similar conditions, favor very similar adaptations.
In effect, each of these lava flows is like rewinding the tape of life and allowing evolution to occur again and again. In each case, we find the dark mice have evolved.
The rock pocket mice show us that evolution can and does repeat itself, and why evolutionary change is never ending. As environments transform, so must the species that inhabit them, adapting and readapting in the great and complex battle of life.
Mister, estás muteado.
Qué menso de mí. Yes. So that's the video, guys. You can make your group if you want, and you can start working on this on your own. Okay. So any questions so far? Do you think that if lava would be red, that the mice would be red?
I think so.
Yeah, of course. If the lava would be green, we would see green mice. Why not? Green is more difficult. It's not really a natural color for the environment. It is if you think about trees, of course, but not about non-organic stuff. So go ahead, guys. Divide yourself in the groups, or if you want to do it alone, you can disconnect and do it on your alone. But start working on it for the time that's left, which is about 15 minutes. And we see each other next week, Wednesday. And good luck with taking your pictures tomorrow. And when you do
Thank you, teacher.
it,
Bye.
bye.
Sorry.
Thank you, Mister.
Thank you.
Thank you.
Bye-bye.